Okay, welcome to the physics class. This is the practical session under electricity. So today we are going to discuss about the potentiometer as a previous lessons. So potentiometer, today we are going to design the potentiometer by using the ruler, a meter rule. We have a wire. We shall also use the resistance box, the galvanometer, together with the jockey and the switches. These switches. For the case of potentiometer, we are going to use a battery together with a cell. You can use two cells or more than two cells, or you can use an accumulator. Okay, so how can you do? You just take a piece of a wire, make it on the top of a ruler, then you can fix it with using a sellotape. After then, connect the circuit as shown in this figure. You see the figure? Okay, after then, you can answer the following questions. You can find the data, then tabulate your results accordingly, then find the resistance, internal resistance and the e.m.f of the cell. This is the aim of this experiment. As we have said that the uses of potentiometer can be used to determine the internal resistance and the e.m.f of the cell. Also, you can compare the resistance of two resistances. Also, you can compare the e.m.f of two cells. Also, you can calculate the voltmeter and the ammeter, and you can determine the internal resistance of a voltmeter by using this potentiometer. But in the case of real-life application, potentiometer can be used as a voltage divider in many electronic circuits. Also, can be used as a volume control in radio and TV receivers. Potentiometer also used in medical equipments, and also can be used in wood processing machines. So, in school level, we shall be going to determine the internal resistance and the e.m.f of a cell by using the method of a potentiometer, but the potentiometer used a designed one. Let us see how our fellow can do it. Thank you.
Okay, as you can see, the circuit is already connected. We will begin, according to our question, we'll begin with the resistance, whereby we are told the resistor is 1. So, in the resistance box, you will remove this, then from there, you will close all switches, switch 1 and switch 2. Then, you use the jockey to find the balancing point along the wire which was placed on the metal rule. Whereby you will find the balancing point right here. Then, you record your data according to what your metal rule reads. Then from there, you return and you remove for the second. The same case, you find the balancing point according to your galvanometer and you record. You do the same for all other resistance. You will do the same for other resistance which you are given in our question, which are 3, 4, and 8. Then make sure you take the reading of balancing point according to your voltmeter, where it's read exactly to 0 point. Then you record your data of the length. After that, according to our question, you are told to record the values of 1 over R and 1 over L. So I will write the values by calculating them. Then after that, after recording all my values, I'm going to plot a graph of 1 over L against 1 over R. Then after there, as you can see my graph, then according to my graph which I draw, there is an intercept which is in 1.8, which is almost to 2. According to the data which I got from my practical, I've brought a graph. As you can see in the graph, there should be always a heading which indicates we are drawing a graph of what against what. According to my question, it was 1 over L against 1 over R. Make sure when you draw your graph, the vertical and horizontal axis, make sure they close each other, and there should be extension from where you end, and there should be indicated 0 so as to show where you begin your plotting. And also your scale, it should be indicated here on top, vertical scale together with horizontal scale. Then when you draw a graph, make sure there should be this slope indication, and from there now I'm going to determine a slope of my graph. Make sure you take consideration the points which you have chosen from your slope indication, whereby my points which I have chosen is 2.6 minus 2.1 bracket multiplied by 10 power negative 2 over, and this I'm taking according to the scale which I've used, over 600 minus 150 multiplied by 10 power negative 3. Make sure you don't forget the scale, which is centimeter negative 1 and the negative 1. Also, make sure you don't forget the scale, and also this SI units, since they are very important in determining slope. So after there, I'm getting my slope is 0.01 centimeter negative 1. Then after that, according to my question, I was told to find e.m.f and the internal resistance. Then from there, according to my practical, the E, it's valid with LO, and also V valid with L. But we all know that E is equals to I R plus this, and V is equals to IR. So I'm going to, E to be equals to I R plus this, which is also equals to KLO. This is my first equation, and also V, which is equals to IR, is equals to KL. This is my second equation. Then from there, so you have IR plus this is equals to KLO, and also you have IR is equals to KL. Then I'll take equation 1 divided by equation 2, whereby when I divide, I get this is equals to LO over L. Then from there, since I was told to plot a graph of 1 over L against 1 over R, so I'm going to make a subject 1 over L. Then here when you divide, you get this multiplied by 1 over LO. So 1 over L is equals to 1 over LO plus this bracket 1 over LO. So Y is equals to this over LO and 1 over R plus 1 over LO. Whereby my Y, according to here, 1 over L. So according to my question here, I can see Y is equals to mx plus c. Now my slope, which I've already obtained, which is 0.01 centimeter negative 1, it will be the same as L over LO. But we all know that this 1 over LO is the intercept, which I can obtain it from my graph. And from my graph, the intercept 1 over LO, which is the intercept, is 1.9 multiplied by 10 power negative 2, according to my scale, centimeter negative 1. So to determine the internal resistance, which is R, it will be the same as saying 0.01 centimeter negative 1 multiplied by the 1 over LO, which it will be, when I try to make here, I will multiply by LO. Sorry. How to get the internal resistance here, you will divide by the intercept which you get. So the R, it will be the same as saying 0.01 divide by 1.9 multiplied by 10 power negative 2 centimeter negative 1. Then I'll get my internal resistance as 0.53. Then from here, also we're told to determine the e.m.f, whereby we also, from the beginning where I said E, it varied with is direct proportion to LO, whereby my LO, according to the experiment, LO, it was 100 centimeter. So E will be the same as saying K 100. So this will be my first equation. And according to the practical also, then the E, it will be the same as saying KL, which will be equation 2. So when I take equation 1 divided by equation 2, which is EO divided by E, it will be the same as saying K 100 over KL, whereby K and K will cancel. EO over E is equals to 100 over L, whereby this L which I'm talking here about is the LO which I've obtained, 1 over LO which I've obtained. So the EO which we are given according to ourselves there, the battery, which EO, it was already 3 voltage. So to get the e.m.f, it will be the same as saying the taking EO multiplied by multiplied by L over 100. By E, it will be the same as saying EO 3 voltage multiplied by the length from this. When I determine LO from here, I get LO, it will be the same as saying reciprocal, which I obtained 52.63 centimeter if you try to find the reciprocal. So I'll insert it here, which it will be 52.63 centimeter over 100 centimeter. When I try, I'm getting my e.m.f as 1.57, which is voltage. So up to here, we've already obtained our e.m.f and the internal resistance. As from my data and all my calculation, you can see the e.m.f which I got is 1.57. This is due to the uniformity of the wire which was used. We can see the wire, it was not exactly uniform. That's why there will be a certain variation of this e.m.f. And also the batteries which I've used, they have been already used. Yeah, so there will be already variation in the true e.m.f and this e.m.f which I've obtained from the practice.
Okay, thank you for watching physics. And today we already said about how to connect it, potentiometer, to create ourselves, and how practical is going on. So be careful when you connect it, your circuit, outside circuit, and downward means primary and the secondary circuit.
And make sure also there should be no loose connection. Make sure everything of yours is tightly fitted in both ends.
So don't forget another time to subscribe, share, and comment. Thank you.